Thank you. It's a pleasure, as always. All right, we'll just jump right into it. I know this is the last session, and you've heard a lot of stuff, so we're going to try and make this enjoyable as well. So I'm sure you've heard or experienced from your own personal experiences that autism involves a lot of problems with the gut, and that's a big focus nowadays. If you go to a doctor and do a workup on your child, one of the first things they're asking you a bunch of questions about bowel habits, diet, and such. So that's the thing we often see. And this little girl is obviously in pain. Maybe she's nonverbal and she can't tell her mom or dad that she's hurting, but she obviously is in pain. She's not feeling well. And often this has to do with the foods we eat or the compounds or products produced as a part of normal digestion. And this is what we want our kids to eat. We want them to eat the fruits and vegetables so they can get the vitamins and minerals and the antioxidants they need to develop and grow normally. And this is the end result we want. We want a bright and happy young child who is, eats his veggies and fruits. And so that's what we're going to be talking about, how to get to that point. So there's a lot of autism does involve digestion. So we need to know a little bit to understand what's going on with the digestive process. In autism, Dr. Tim Bowie has written a couple of papers and detailing studies which show that many children on the spectrum have problems with digestion, and often this is related to the fact that they cannot break down carbohydrates in their diet very well, starches as well, and the transport of sugars out of the gut into the systemic circulation can be impaired as well. As well, there's fewer short-chain fatty acids produced, and these come from the omega-3s and fats that we include in our children's diet, the fish oils and such. Oftentimes these GI problems are correlated with behavioral problems as well, and this makes sense. If you yourself have a stomach ache or you're cramping or bloated, it's not going to put you in a very good mood. And if you're a child and who can't communicate very well, this can often result in acting out and behavioral problems. And a lot of this is just related to the inefficient breakdown of food proteins. We can get into the other food groups as well, but food proteins have a special effect on kids, and that's what we're probably going to emphasize the most in this talk. Now, you've probably heard both terms, food intolerance and food allergy, and there's a little bit of difference, and though many of us will use the terms interchangeably, but I do want to define them a little bit. A food allergy is something that occurs very quickly, even with very, very small bits of food. Whereas a food intolerance is usually dose-related. You can handle a little bit of it with larger portions of it, then you start getting some symptoms. Food allergy is going to occur every single time it happens, and a food intolerance, it may or may not, again, because it's dose-related, or the occurrence varies due to the way the body reacts to that particular food protein. Food allergies involve the immune system with histamine release. Histamine is a compound that causes blood vessels to dilate and expand, and you get a red flush. You feel warmer. Food allergies, there's also other problems with histamine release, but the immune system is fired up, ready to respond. Whereas a food intolerance is mainly going to be manifested in the digestive system. But remember that the gut, the intestinal tract, is a large part of the immune system as well. So there is some overlap. And much more people have food intolerances than food allergies. So what causes food intolerances? Sometimes it's the absence of an enzyme needed to break down the food. The most common one is lactose intolerance. And lactase is an enzyme that's programmed genetically to reduce production after age 6 because it seems we are weaned from breastfeeding and are onto solid diets and don't have a intake of dairy or milk products. But we often do. So those of us who are above 30 often develop symptoms where we shy away from dairy. We don't want the bloating and the gassiness, the cramping and the diarrhea associated with lactose intolerance. Sometimes it's due to a specific defect in the gut, such as irritable bowel syndrome. And that just can occur from a number of reasons. Something irritates the bowel, it reacts, and you don't feel well. Food poisoning, almost all of us have had this one time or another. I've had it in my travels, once in Barcelona and once in Alexandria. So neither time was very fun. Something we want to avoid. I don't recommend it at all. Sometimes it's just a sensitivity to food additives, food dyes, artificial colorings, artificial flavorings. We can react to it. Sometimes anaphylactically, and that goes over into the other category of a food allergy. So that's one thing. Sometimes it can be the artificial sweeteners as well. So it can be almost anything, even including natural colorings or natural flavors as well. Just because it's artificial doesn't necessarily mean that it's something you're going to react to. Or the other way around, even just because it's natural doesn't mean we can automatically tolerate it. Recurring stress or some kind of psychological factor can play a role as well. There's definite communication between the brain and the gut, and as well as your mood or anything that affects the mood is going to affect the gut. Anytime you get some kind of bad news or something that frightens you or is of great concern, you can actually feel your gut cramping up a little bit. So there's a reason for that, but just suffice to say that it does occur. Or it could be something of a disease that's much more serious, such as celiac disease, which is an immune-related disorder in which the intestinal tract reacts to a combination of gliadin combined with a certain antibody, and the immune system makes another antibody or reacts to that complex and causes great damage to the villi in the small intestine. Food intolerances in autism, there's several. The main ones you know about and heard about are wheat, which has the protein gluten, and dairy with the protein casein. And that's why we have the gluten-free, casein-free diet. These two proteins are ubiquitous in the Western diet. It's very hard to avoid them because they're used in so many different foods. Soy protein as well. All of these have something in common in that when they're broken down during digestion, they produce certain peptides that have certain bioactive effects, and we're going to get more into that as well. Now, polyphenols are something that's good. They're found in the brightly colored berries and fruits that doctors encourage us to eat. They're the anti-carcinogens, the anti-mutagenic factors that we need. But often children on the spectrum seem to react differently. Either you see the red flush, the red ears, aggressive behavior sometimes. For some reason, we're not sure why that occurs, but it's something, and unfortunately, it often means a restriction of those fruits or vegetables that you want to get in the diet. So with the proteins, it's peptides that can be the problem. With fruits and veggies, sometimes it can be the polyphenols. And it's not that we're worried about getting rid of the polyphenols, but what happens when they're made or when they grow, the polyphenolic compounds become or have a sugar group attached to them. And somewhere in our GI tract, we're supposed to have an enzyme that removes that, and that makes the polyphenol able to be absorbed. If the sugar group stays on there, it can't be absorbed, so it just stays in the gut. And I think my theory is that at some point you get a certain amount of these glycosylated phenols in the gut, and it may trigger some type of histamine reaction, and that's why you see the red cheeks and red ears often with these kids. Starch and sugar intolerances. We don't think of starch and sugar being an intolerance, though we know that kids can react to starches and sugars as well. But again, we're going to go back to the most common intolerance, and that is lactose intolerance. And lactase is an enzyme that breaks down lactose into glucose and galactose. And it's been on the market for decades. So it's been around. A lot of people use it to be able to ingest dairy products. Diets that are specific to the autism community, well known. You have the gluten-free, casein-free diet. SCD, or specific carbohydrate diet. Both of these have been noted to have caused great improvements in a lot of children, but it involves major elimination of major food groups, and it can be quite difficult. And there's other diets as well. Body ecology diet basically attempts to change your diet so that it benefits certain flora in the gut. Low oxalate diet. Oxalates can be problematic, but I can tell you this is one diet that is really very easy to get your kid on, because what kid doesn't want to be told, no, you can't eat that spinach or broccoli, it's got oxalates in it, and say, okay, no problem. But the oxalates can be almost in the same category as the polyphenolics, in that they cause sometimes behavioral problems as well. They can be problematic for those who have kidney stones that are calcium oxalate in nature. So that's often, that diet is often prescribed for those dealing with kidney issues. GAPS diet, gut and psychology syndrome, basically just confirms that there is, or the old adage that food is medicine is true. What we eat can affect the way our brain works and what kind of mood it puts us in. So this ties together the fact that the gut and the brain do communicate. So this is an attempt to change the diet such that you enhance that communication between gut and brain. Enzyme supplements have been around for decades in a number of forms. Like I said, we've had lactase supplements since the 60s, and other enzymes have been around, bromelain and papain and such. The enzymes we have now that are targeted toward the autism community are meant to complement the restrictive diets. The main issue and the main benefit and characteristic of plant-based enzymes is that they work in the stomach and the GI tract because they're acid stable. And this allows digestion to occur within the stomach some 2 to 3 hours earlier than it would occur normally, because it won't occur in great amount until the food moves out of the stomach into the small intestine, where it encounters the pancreatic enzymes. So you can get a head start by using enzyme supplements and getting the food started to break down within the stomach. The other useful thing about enzymes, diets such as the gluten-free, casein-free diet focus entirely on wheat and dairy. But they miss the point that there are other foods that produce the peptides that cause problems. So, and it just came to light just a few years ago that soy protein, when it's broken down, produces soy peptides that can react the same way as glutamorphin and casomorphin, which we're going to get into a little bit, address those as well. So the enzymes really don't care where the protein came from, or what food it came from. If it's a protein, it can be broken down by the enzyme. So this way, that's why a lot of people who have been strict or kept their kids strictly on a GFCF diet often find improvements when they add enzymes onto that. So you see another benefit or another level of benefit when enzymes are added to the diet. And the fact that many who've used the enzymes instead of the diet see similar benefits actually means that they are working in the same manner. The diet's simply removing those proteins that are causing the problem. The enzymes are simply changing those proteins. Either way, the bottom line is that you're getting benefits from working on those, from avoiding those proteins or changing them. So let's talk about proteins for a little bit. Proteins are large molecules. They can vary from any number of sizes depending on the number of amino acids that are linked together. So there are various enzymes that break down different proteins. And the whole idea in digestion is to break something large down into something smaller so that we can absorb it and the body can use it. So the first part of digestion is to break large proteins down into small peptides. And then from that, you use other enzymes to break down these individual peptides into their smallest unit, which is the amino acids. And from this, once you have a pool of amino acids derived from the food that you eat, the body can then use those and construct its own proteins. Starch digestion goes much the same way in that you have complex carbs, which are basically sugars, simple sugars linked together by glycosidic linkages. You have enzymes that break these bonds into what we call trisaccharides or disaccharides, which would be 3 or 2 sugars linked together. And then you have other enzymes that break those saccharides down into single units of sugars, usually glucose. The body uses a lot of energy to try to convert much of the food that we eat into glucose. So it's obvious that carbohydrates can be broken down into glucose. There's pathways in the body where even proteins can be converted into glucose if necessary, if the body deems it necessary. We haven't talked about fats, but triglyceride fat digestion is becoming something more noted and more important. And it's a little bit different. The fats that we're talking about as far as breakdown by enzymes are the triglycerides. And all triglycerides are made up of a glycerol backbone with 3 positions. And with these positions, you have different fatty acids attached. And this is they're numbered, 1, 2, and 3. So lipase is an enzyme that breaks down this linkage right here, releasing the fatty acids. And there's different lipases for different positions that are specific for these different positions. Some want to just, can only break down the 1 position, or maybe the 1 and 2, or the 1 and 3. But you can get total breakdown or release of the fatty acids by using an appropriate combination of different lipases with different specificities for these positions. But what you end up with is, from the triglyceride, free glycerol, which can be recycled, and a free fatty acid. Unlike triglycerides, which your doctor always tells you to try to keep low in your bloodstream, the fatty acids are something that's considered nutritional. And these, again, are the building blocks of other compounds that the body needs, especially for nervous system and brain development. So what exactly are enzymes? I've been talking now for 15 minutes about enzymes without really defining them. And it's important we do so, because if I say vitamin C, you associate that with something specific, like colds or flus, or vitamin E, heart health. Ginkgo biloba, you think of keeping good memory support, those type of things. If I say enzyme, it's a little bit difficult. But the textbook definition of an enzyme is that it's a specialized protein that catalyzes or accelerates chemical reactions. In the body, these are reactions that would not occur under conditions suitable for life. So unless we had those enzymes there to promote the reactions. We're going to talk a lot about protein breakdown. We can go into the laboratory and put a protein in a test tube, and we can break it down completely to its amino acids, but I would have to use very, very strong hydrochloric acid, seal the tube in a vacuum, and put it in basically a pressure cooker for 20 hours at very high pressure and temperature. And after that, we would have a soup of amino acids. The protein would be completely broken down. Enzymes can do the same thing at room temperature in water in a matter of seconds to minutes. So they are very powerful, and they are needed All living things contain enzymes, and we need enzymes to have life. The other neat thing about enzymes is that they're unchanged during the reaction. A catalyst is something that promotes a reaction but is itself not changed. And this is important because it means that a very small amount of enzyme can do a lot of work. As long as the enzyme is not harmed, it can't get used up. So one enzyme can just keep cycling through and do millions or billions of reactions in a given amount of time. So that's a very important characteristic of enzymes. They're also specific for usually a single reaction. A single chemical pathway or reaction is usually requires a one type of enzyme, one enzyme. So, and this is a good thing as well because you don't have enzymes going rogue. If you have a lactase enzyme, it can only break down lactose. It can't break down a protein, or it can't break down some other sugar. It can only break down lactose. If lactase is around and lactose is not, the enzyme does nothing. There are some 4,000 enzymes already characterized in the human body, and there's probably that many that have not been discovered yet. So it's an active area of research. It was the basis of my graduate work, and as well as my postdoc and other academic research, as well as research after my academic years as well. But and I remember very well my professor in grad school, who was a renowned enzyme biochemist, said, it's the metabolic enzymes, the enzymes within cells. That's where it's at. He said that's where all the action is occurring. Don't mess around with digestive enzymes. They're boring. They don't do anything but break down food. So unfortunately, I didn't follow that. I followed it for a while, and actually it was probably the one thing he was wrong about. Metabolic enzymes we can't do a whole lot about. You can't really take it orally as a replacement and have it get into the cell. Enzymes are just too big, and there's no way to instruct the enzyme to get into your kidney or liver or heart or wherever you're missing an enzyme. Digestive enzymes, however, which is what we're going to be talking about, they're the ones that break down the proteins and carbs and fats, and that's all they do. But if you think about it, that's actually a really important job. Otherwise, we couldn't survive. You can't rub an apple on your arm and hope to absorb the nutrition from it. You have to digest it. And since these enzymes are actually secreted by cells in the intestinal tract or the pancreas, and they're secreted so they go outside the cells. So this is something we can replace. You can take it orally and have it work in the gut where it's supposed to work. We can break down the digestive enzyme category to two more. You can call pancreatic enzymes or animal-based. Your doctor can prescribe pancreatin or Viocase or Creon for you as a pancreatic enzyme replacement. The pancreatic enzymes are not acid stable, so they have to be enteric coated, and they will go through the stomach, and then when the stomach empties into the duodenum, the pancreatic enzymes can start working. The plant-based enzymes, and these are the ones derived from fruits like pineapple and papaya, or fungal organisms like Aspergillus oryzae, Aspergillus niger, and some bacterial enzymes. These are different. They are acid stable. And while they can do a lot of the same thing that the pancreatic enzymes do, they are slightly different. So they're the same yet different. So we'll talk more about those differences. As I said before, the whole idea of digestion, it's important. It's what we need to survive. And the whole idea is to break down something large and whole into something that you can absorb and use within the body. Enzymes are found in saliva. If you took a cracker or a piece of bread and chewed it and held it in your mouth for a while, you would find it start tasting sweet. There's an enzyme in your saliva called amylase, which converts starch to sugar, and that's why you get that sweet taste if you keep it there long enough. There is a couple of enzymes in the stomach. People think a lot of digestion occurs in the stomach, and there really isn't. The stomach is basically a grinder, blender, and it's just trying to get the food into a certain consistency and texture so that it can be really digested further on in the small intestine. There is a major protease in there called pepsin that's only active under pH 5, so that's why you need acid in your stomach to activate that pepsin enzyme. And pepsin is important because it kickstarts the pancreatic enzymes once the food mass moves into the duodenum, or the first part of the small intestine. So H2 blockers, or if you're taking Pepcid or one of those Prilosec, one of those H2 blockers that decrease the acid, that can help your heartburn and reflux, but it might hinder your digestion as well, because it's going to keep the pH, by inhibiting acid production, it's going to keep the pH higher, and therefore you don't have pepsin there to, one, start a little bit of the digestive process, but more importantly, it's not active to kickstart the pancreatic enzymes later on. The pancreas continually produces enzymes and stores them in the pancreatic duct. When the cell walls of the first part of the small intestine detect the acidity as the food moves out of the stomach, it signals a couple of hormones, and it causes the pancreatic duct to squeeze or convulse, and it shoots out the pancreatic enzymes along with a lot of sodium bicarbonate to neutralize the acid. And in this way, the pancreatic enzymes can start working. They become activated by the little bit of pepsin that was in there. Pepsin removes a couple of amino acids off the pancreatic enzymes, and that activates those enzymes, and they start working. Further on in the intestinal tract, the cells lining the inside of different parts of the intestinal tract also produce enzymes. They produce mainly some carbohydrates and like lactase and isomaltase, but also some peptidase enzymes, which do the finishing work on those small peptides that I showed you earlier. So the whole process of moving, you start with large amount of food, or food in whole form. You chew it up, so you mechanically break it down. The stomach kind of churns it and further mechanically breaks it down and prepares it gets it in, denatures, the acidity denatures proteins, which unfolds the protein from a globular form into a linear form, and this allows the enzymes more access to the food mass as it travels through the intestinal tract. Also, we don't want to neglect the probiotic bacteria. They play an important role as well. They're further down in the colon, but they produce unique enzymes that we don't. So they can break down certain things like cellulose, which, for example, that's why cows eat grass. They're eating mostly cellulose, hay and grass. And their four stomachs contain a lot of different bacteria which produce enzymes to break down those, break down the cellulose to sugars. So it's very important, and depending on which bacteria you have growing in your gut, you're going to have different enzymes. And this is why people's digestion can vary, why their diets can affect their moods or their health. And we're seeing a lot now that you may hear the term the microbiome, and that's a big point of emphasis now in the autism research community, is to look at the different bacteria in these kids and see if maybe they play a role in behavior and gut health as well. A lot of the different bacteria are anti-inflammatory. Others promote inflammation. So depending on which bacteria you have in your colon depends a lot on your health. You can get, like I said before, you can get pancreatic enzymes from your doctor by prescription. Plant-based enzymes are available over the counter, both in oral form. And again, we want to emphasize that the plant-derived enzymes are acetable, can work in the stomach as well as the GI tract. So how does all this exactly help us and help our kids? Well, adding enzymes, the whole idea is to break everything down. And I think because we have the diet we have, which is so varied, also the fact that we have a lot of GMO foods, and there's now evidence that genetically modified food proteins or food proteins from genetically modified crops, we have a harder time breaking them down. Most likely because we haven't involved the enzymes to adequately break down those different proteins from the different genes that may be there. So by adding supplemental enzymes, you're adding another set of knives, chainsaws, cutters, whatever, to the breakdown of the proteins. And this is going to prevent the production of what we call exorphin peptides as well as other peptides. This word, you've probably all heard of the term endorphins. Those are peptides we produce under moments of stress. They are opiate in nature. They make you work harder and you feel less pain. They're opiates. But endo means they are from within, so they're produced by your body, within your body. Exorphin, exo means outside. So these are opiate peptides that are produced outside your body. So these are derived from certain food proteins, such as gluten, casein, soy protein, and as well as others. So the whole idea behind the GFCF diet is to avoid exposure to these peptides, which occur under normal digestion, by just eliminating them from your diet. The idea behind enzymes is to use the correct, appropriate proteolytic enzymes that break down proteins, to address these particular proteins, break them down differently or more thoroughly, and so that you actually prevent the production of those exorphin peptides. Again, that's an important point. If everything else seems hazy or if I'm not making it clear, remember this, that this is why enzymes can be so helpful. The fact that they're acid stable, they can work in the stomach, and where peptides are not absorbed, and they can do all this before the food moves into the intestinal tract, where absorption is supposed to occur. So that's really important. In the same way, we can talk about proteins, we can talk about starches. Starches are what cause a lot of the gas and bloating, because I know we think in terms of sugar feeding yeast and bacteria, but actually it's the carbohydrates, undigested or partially digested starches and carbohydrates laying around in the gut that become a food source for bacteria, both good and bad, and things like yeast and other fungi. And as these bacteria grow, they bloom. I mean, the population increases dramatically very quickly, and they're gas producers. So they produce a lot of gas, and you get a lot of bloating, and that's one reason why you have the enzyme BINO, because beans, legumes, cauliflower, broccoli, those things have a carbohydrate in them that we can't break down. Those they're called stachyose, raffinose. There's a whole set of them. And there's an enzyme called alpha-galactosidase, or we just call it alpha-gal, that we don't produce, but it specifically breaks down those complex carbohydrates. So you can add that enzyme to your diet, and it will help break down those starches into sugars. Again, they're not laying around the gut, they're not feeding bacteria, and so that's one way. Basically, you're just keeping, if you think of the gut as a house and you're just keeping the house clean, you're preventing a lot of pests and vermin from causing problems. A lot of the supplemental enzymes you can purchase may mimic the enzymes produced by some probiotics as well. So you're just bypassing the middleman. Instead of waiting for the probiotic to take a hold or to start growing in your gut and then producing the enzyme, you can just take the enzyme and go have it go right to work. And like I mentioned, we're not going to talk too much about the polyphenol issues, but it can modify polyphenolic compounds such that they're absorbed and you can derive the nutrition from those phenols as well. I probably should have put this in there sooner, but this just kind of shows you the stomach. I call it a safe place for foods. It's got the muscle, it's very muscular, and that's why it moves. It squeezes and bulges and such, and that's why you feel it moving around. But depending on what type of meal you ate, the food's going to stay in here for 2 to 5 hours, especially high-fat meals. The more fat you have in the meal, the longer it's going to stay in the stomach. Minimal food breakdown, just because there's only, like I said, pepsin and a couple of lipases in there. So you have this, and you can see how you would get reflux, because if you fill up your stomach and you push the food up here, you have this part here. If you're sleeping at night, you might know, this is just kind of a fun fact to know. Roll over on your left side if you've been sleeping on your right side or your back for a while. Oftentimes you burp because you have this bulge here, and this is where the gas accumulates in the stomach. You roll over, you press down on that bulge, and you burp. So that may be important where you sleep in the bed, depending on who your partner is. So just keep that in mind. But here I want to emphasize that the supplemental enzymes you take that you can buy in the health food store or other companies, they're shifting the bulk of digestion to the stomach, upstream, up further. And this is, I think, very important to addressing a lot of the problems you see with autism. Again, I'm repeating myself, but they can address enzyme deficiencies, but I don't think it's so much I don't talk in terms of being deficient in enzymes. We just don't have the enzymes in the stomach. So we're just kind of moving a mass of, because in reality, our pancreas produces plenty of enzymes, usually more than enough to break down a meal. But with certain food intolerances, you don't want that breakdown to start occurring in the intestinal tract where it can be absorbed. You want it to start sooner and address some of those problem foods. And that's why I refer to the stomach as a safe place. The other nice thing about enzyme supplements, they're very safe. There's no toxicity at any dose. We always use mice or rats to determine safety and what we call the LD50, how much of a dose requires to kill 50% of any number of rats or mice. And the only way you can use enzymes to kill rats or mice is to bang them over the head with a bottle repeatedly, and that might do it. They're just really, really safe. They're just proteins, and they're just, to the body, they're just seen as another food protein. Anyone can benefit from a good enzyme product. Even I did when I first started working for an enzyme manufacturer. I didn't believe it. I thought my digestion was fine until I started taking enzymes. And I felt much better. Structure determines function. That's in biochemistry, that's one of the dogmas. That's what we go by. How something is made determines what it does, which makes sense. If you have a toaster, it's made to be a toaster, it's going to toast toast. It can't wash your clothes or dry your hair. If you change the structure of that toaster, you change its function. So if you take a hammer to it and start beating it up, you change the structure and you change the function. It's probably not going to work anymore. And if you think of proteins as words, and think of, since amino acids make up proteins, amino acids would be like letters making up those words. And just as the meaning of a word depends on the sequence and which letters you put in, how a certain protein works depends on which amino acids and in what order you put those amino acids. So again, if you change the structure, you change the function. So it just like, and here's just a quick illustration. M-O-T-H-E-R, and that means mother. If you remove two letters, E-R, you have a totally different meaning. You changed it to mean moth. So again, you changed the word, you changed the meaning. Same thing with proteins. Again, we're going back to the fact that we have food proteins, and if they stayed as proteins during digestion, they wouldn't cause the problem. It's the peptides that are produced from these proteins that cause all the problems, such as the exorphin peptides, like casomorphin, gliadomorphin, soymorphin. Even spinach leaf has a particular protein in it that can produce an opiate-like peptide. A lot of people don't know that, but see, it's under the radar. There's more than likely we're going to find other foods as well. And they all have typical opiate actions. And if you think about it, a glass of warm milk at night, yeah, it helps you sleep because you're getting a little bit of an opiate reaction. So, and it may explain why a lot of these foods, breads and biscuits and such, are considered comfort foods. They make you feel good. And you can see these in kids. They often will crave these foods. They're basically addicted to the little bit of an opiate action that they're getting. So, again, I may be beating you over the head with this, but I really want to emphasize this. But if you look at what happens under quote-unquote normal digestion, and well, let's take the protein casein, which is what you'll find in a dairy product. So this is the casein molecule from bovine or cow. And these X's are other amino acids in the protein we don't care about. But we do care about these particular amino acids in this sequence: tyrosine, proline, phenylalanine, proline, glutamine, proline, isoleucine. Though this is part of casein. In the stomach, if the pH is less than 5, pepsin becomes active. Pepsin has a certain, it's a protease. Every enzyme has different criteria. Pepsin likes to work on a certain peptide bond, the bond that links different amino acids together. So these are unique. If you have two different amino acids, you have different peptide bonds. So pepsin likes to cleave right there. And in the stomach, under pH 5, it'll clip that right there. So you've clipped the casein molecule. It's not really casein anymore, but it's just a fragment of casein. Later on, 2 hours later, food moves into out of the stomach into the duodenum, where it encounters pancreatic enzymes, one of them being elastase. It's a different protease, different from pepsin, different from other proteases. And again, it has a different peptide bond it likes to clip. It wants to clip right there. And it does so. Now, you've produced this peptide, and this is casomorphin. Again, structure denotes function. So this particular structure produces an opiate-like effect when it binds to the opiate receptor, which there are in the gut and the brain. So incomplete breakdown of food proteins produces bioactive exorphin peptides. So, what to do? Back in '99, I invented an enzyme formula used by it was the first enzyme product introduced to the autism community. After the fact, when I got feedback that, wow, this is really helping kids, I said, well, I wonder why. I thought all these did was help with gas and bloating and, regular food digestion. So I started looking, and there's this one enzyme called DPP4, or dipeptidyl peptidase 4. It's the only known enzyme to break down exorphins, which are produced in the gut. So lights started going on in my head, and I wondered if it was in the gut. Sure enough, it's produced by cells lining the GI tract in humans and just about every other living mammal. We went down to the lab. We took that formula that we had produced and tested it and found that it contained significant amounts of this DPP4 activity, which had not been known prior to that. Enzymes, commercially available enzymes, are actually mixtures, and they're standardized on one particular enzyme activity, and there's other contaminating enzymes there that we may or may not know about. So until we have a reason to look for them, we don't know if they're there. So once we developed the assay or the means of testing, we found that it was there. So what does DPP4 do? It's a very interesting enzyme. It likes to remove amino acids in sets of 2s from peptides, but it has very, very strict rules as to how it works. Rule 1, it can't be, the last amino acid of the peptide can't be attached to anything. It's got to be unblocked, and this is the N terminus. This is the C terminus. So this has to be unblocked, not attached. Rule 2, proline. It doesn't care what amino acid is here, but proline has to be the next to the last, or if you want to use a big term, penultimate amino acid on this end of the peptide. So if those conditions are met, you get cleavage right there. and it removes those two amino acids at once. So let's go back here. Back to the casein. It's in the stomach. This time, little Johnny ate some cheese. It's in his stomach. His mom saw him, so she gave him some enzymes that have DPP4. Let's see what happens. DPP4 could work there, but it can't because Rule 1. This amino acid is blocked. It's attached. So DPP4 can't really do a thing at all right now. So what to do, what to do? Well, if you have pepsin comes into play, and it does its thing, and it does its clip right there, all of a sudden DPP4 can now go to work. Now, important to note, you've not produced casomorphin. This is still a casein fragment, so you don't have an exorphin peptide running around your stomach yet. But DPP4 now can come into play because this is now unblocked. So it goes down, and this next to last is proline. And there, you have changed the structure of this fragment. If this were to go on and encounter the elastase enzyme, you would not have casomorphin, you'd have something else. But look here, look what we got. The enzyme, the DPP4 sees that the rules are still in play. Unblocked amino acid, and proline is the next to the last amino acid. So it shifts over, sees that, voila, it clips off another two amino acids. And look here, same thing, unblocked amino acid, proline, next to the last, shift over, grab it, clip it. All this before it was even made into casomorphin. All this occurred in the stomach where you can't absorb peptides. So no casomorphin is formed even though little Johnny ate a bunch of cheese. So, except I'm not comfortable with just DPP4 because you had to have all that other stuff happen. So a lot of other things had to occur. But what if we had other proteases, like protease 4.5? It's a different protease. It has a different peptide bond specificity. In fact, it likes to clip right there. And if it does, look what's happened. You've clipped it right where casomorphin should have been, but it can't be produced if it's already cleaved there. What about another protease? It has a different specificity. It likes to clip, I think, right here. That's where it clips, yeah. So it does its thing. Two different proteases working at two different sites. They may work together. They may do that, but still, you cannot make casomorphin now because you've already removed that. So I think the best thing to do is to have multiple proteases. Let's combine them all. Let's have the DPP4 there along with other proteases. So we basically are increasing our odds of changing the proteins such that you don't produce the peptides. Now, interesting enough, some other labs may have taken note of this. Like I said, this is all going on in 99 and 2000. Other groups, one at Stanford, started looking at enzyme cocktails very similar. They were from bacterial sources. And then they started using recombinant type enzymes, but they are very similar to the enzymes that we showed earlier. And again, they saw if we use, but they were interested in celiac disease, basically looking at something that would break down gluten so it doesn't produce gliadin, the peptide involved in celiac disease. So they found the same thing. If they used just a single enzyme, they didn't get that much occurred. But if they used a cocktail or several different proteases, they could break down the gluten so that you don't produce a gliadin peptide. So it's actually on a fast track through FDA, and it may be that this enzyme cocktail could be a prescribed drug treatment for celiac disease in a few years, which that would be, to me, awesome, because it tends to validate what we've already been saying. Carbohydrates enzymes for starches and carbs. Like I said, Dr. Bowie's work shows that a lot of these kids, because they have gut wall inflammation and damage, if you damage the cells that produce the enzymes, you can't produce the enzymes. So they may be low in disaccharidase enzymes so that they don't break down those complex carbs and starches, which then allows bacteria and yeast to feed on on those compounds, bloom and cause problems. They're also osmotic. They draw in water, and that's why you get the loose stools and such. So you can use enzymes to break down the starch, amylase, glucoamylase, lactase to break down lactose. All of that helps decrease the carbohydrate load. And again, it's accomplishing what digestion is supposed to do, break down large molecules into smaller ones. Enzymes for polyphenolics, this may be in your book. I'm not going to talk about it too much just due to time. Do note, I'm one of these people, raw veggies can be hard on the GI tract, but there are enzymes such as xylanase and cellulase that help break down the fibers, not completely, but fiber and cellulose is a very complex carb, and it requires multi-enzymes to completely break it down to sugars, but we can use these to get partial breakdown of the fiber and actually help create a gel which softens stools if constipation is a problem and the packing of overly firm stools can be a problem. This can actually solubilize and soften the stools. Most other enzymes tend to firm up stools. So look for a xylanase-based. This is a very interesting enzyme. I think it's very interesting how it helps with the phenolics as well. I think there's something else going on there that's really interesting. Even adults. I have a large following of moms who rely on their Cabernets and stuff to get through the week. And they assure me that taking a xylanase-based enzyme product can prevent their flushing that they often get, and sometimes the little headaches they get, which could be a phenolic problem as well. We think it's salicylates maybe, but it could also be phenolics as well. So it's not just for kids anymore. So very quickly, enzyme dosing is going to, because people are different, their guts are different, their diets are different, experiment. You can, because there's no toxicity, so experiment a little bit. You can, usually there's some recommendations on the bottle. You can follow those, but feel free to experiment. Take them at the beginning of the meal or slightly before, because there's usually a capsule that has to dissolve and the enzyme powder has to dissolve, and then that takes about 20 minutes. So you want to prolong the contact time between enzymes and the food, so that you give the enzymes as much chance as possible to break down the food while it's still in the stomach. You base dosing not on body weight or age, but on how much they eat. Remember, you got that window of 2 to 3 hours, usually on average. So if you eat a lot of food, you may need more enzymes to do the work in the same amount of time. And enzymes aren't going to interfere with most medications or other supplements. They're only going to work on proteins, carbs, starches, and fats, triglyceride fats. And it doesn't have to accumulate. It's not going to get into the body. It's only going to stay in the GI tract. So it should work the first time you take it. You should. It'll work on the food, on the meal you took it with. And it stays with the meal. So the enzyme you took for breakfast isn't going to be there to help you for lunch. So repeated dosing with each meal may be. In fact, we see best results with consistent dosing with at least 2 meals a day. Always look, never buy enzymes if the supplement facts box only has weight units, like milligrams. That tells you nothing. What you see in the supplement facts box is a contract. This has to be true or FDA will come down on you. So you can have 500 milligrams of an enzyme blend, but you can put it in an oven at 800 degrees. It's still 500 milligrams, but it's not going to be active. So look for this. You may not understand what these are, but it assures you that the enzymes have been tested and that it has to have this amount of each. Whatever it states on there has to be true. If it's not, if it's a fraudulent product. So it has to be within 10%. So it's important that you see these numbers and units of activity. It's a guarantee. This is my contact info. Go to my website. There is a ton of information, videos, webinars, FAQs, that type of thing. We've only touched the surface of it, of this whole issue, and I'm always available by email or toll-free number if it's urgent. I like email because it gives me time to compose an answer and to seem like I'm a lot smarter than I really am. So I appreciate that. But you can always call and discuss. This is my job, is education now. I've got good people that run my business and do the daily work, so I can scroll through the internet and play games and talk to parents. So anyway, I'm there. So this is it. I'm done. Thank you.
We are very grateful to Dr. Houston coming and giving us his expertise. I would say he mentioned that there's no harm taking these with medications, which I totally agree with. I deferred to and called for the help of Dr. Houston when we were developing some work on some of the research we were doing with medications for the immune system, but they contain lactose from dairy because that's a packing agent in the tablets. So he and I talked about that, and he gave me advice I could pass along to the patients where you would take the enzymes that digest the carbs, and the lactose always comes with some casein because it's a cheap packing agent they can get for the drug industry. And 1 week it comes from one supplier, and the next week, even though the drug company is the same, their suppliers are all over the place. So we encourage our patients to take the Houston enzymes with the various medications. A lot of these patented medications that you cannot get compounded, if you're familiar with that, they've got phenols in them, they've got starches, they've got some proteins, they've got carbs in them, and things of that nature. So the enzymes, with sometimes the only time, some of our patients, the only time they take, because they're on these various restrictive diets, the only time they take the Trienza, which has got kind of everything in it, or the carb digesting enzymes is with their medications, So, and many of them have spoken with Dr. Houston on the phone. He likes you to call on the internet, but he will take your phone calls too. He took mine. So, any other questions though for Dr. Houston? This is, we don't have another speaker coming up because this happens to be the end of the day. So, if he's willing to stay, I think he is. He's here for the whole conference. Either the folks with the table, we've got him and two people in the room. Yes, for Dr. Houston, go ahead.
As far as recommending trying enzymes, I would say in replacement of, but in addition to a gluten-free basic diet, do you suggest staying on the diet for a couple of weeks after the enzyme starts and then do tests kind of thing, or do you have a protocol that you typically follow?
Yeah, I remember the Firestone we created when we first came out with the enzymes, and me just being a scientist, I said, yeah, when someone asked, what can the enzymes do what the diet does? I said, well, yeah. And I was seen as trying to get parents trying to encourage them to go off the diet, and I'm not. The diet is a great help, and if someone can do it, then I'm all for it. However, I'm also a pragmatist, and I know reality can take a big bite out of things. So it's stressful and hard. So, yeah, we always say if you're already on the diet, just add enzymes into it and see what you get. You should see something above what you're doing. And then, if your child is high functioning and he's 12 or 13 and really wants to be accepted by his peers and really wants to go out and have a pizza, then you could just kind of find out if he can tolerate a slice or two of pizza if he takes the enzymes. And this is not conjecture. It's been over the past 14 years we've had many, many families and not do our bidding, but they've gone off the diet with the enzymes. And again, I say parents have a choice. So it's not my job to judge them how they raise their kids or what they do. So as long as they're given honest information, they can make the choice. But yeah, try to stay on. Don't make drastic changes. Ease into everything, and always if you want to do a challenge, just make sure you give a lot of enzymes and use a small amount of a challenge. And if that goes well, then you can increase the amount of food or decrease the enzymes or whatever. So again, experiment it. That's my motto on that anyway. Anybody else? We do have a booth. We'll be here for at least another hour or so, and we'll be here tomorrow throughout. We're not breaking down till after lunch. So again, I'll be happy to talk to you if any other questions now or later, wherever.
These are my chewables. I take the Trienza. And we sometimes use those, too, for lower GI function. Dr. Houston didn't have hours and hours. He could give the whole, day or speak several times on all these things. But the lower bowels, he just touched on. A lot of the kids will get better, even if they have diarrhea. Sometimes that'll get better. And the other thing is, and I know he only had a chance to touch on some things, there are some kids that are resistant, like the nophenol and things, and I know you were able to touch a little bit, Dr. Houston, but the enzymes in our natural systems that we produce and the products that the Houston enzymes have are also germ killers, and these various job of enzymes is to kill germs too. So some of the kids that are resistant to yeast issues and all that, and we virtually always use them with the carb-restrictive diets because of that bloating and gas buildup and things like that. So they can be sometimes. It's easing into it is what we do too. So that's good advice. Sometimes people will feel like they are going to give up if they get release of some of these toxic peptides in the beginning until some of these debris items, like Dr. Stoller talked about biofilms and all that. Sometimes it takes weeks for those to be cleared out and the gut to heal till you see the full benefit. We have, on average, a 10-day build-up. That's basically what Dr. Houston just told you, that we do it slowly and we build up. We'll do 1/2 dose for 1 meal a day for 3 or 4 days and then build up, and then sometimes back off and then build up a little bit more and go slowly. The chewables taste great. Sometimes I have to be restrained to not eat them like candy if I haven't eaten anything that day. So, all right. Thank you very much, Dr. Houston.